So, rate of change. Ratio comparing how one quantity changes relative to another. So simply, if you have a table that's changing y over changing x. So sometimes I'll have it written down in words. In terms of symbols, you might see a triangle with a y over a triangle x. So the triangle represents change, represents the word change. You will see that symbol more in pre-calc and in calculus, but at least this way you know what it is. They're not talking about triangle y and triangle x. Mostly because you don't see either shape here. Alright, so example 1. Find the rate of change in cost relative to the number of people, and we're using the table that they provided for us. So, in this case, our rate of change is the change in cost over the change in the number of people. So essentially we are looking for what is happening as we go down the table. As you go down the table, as far as the number of people go, you have 6, 9, 12, 15, so you're going up by 3. Total cost, 52, 58, 64, 70, going up by 6. You're fine. So your change in cost is $6. Change in people is 3 people. And then you divide it out. 6 divided by 3 means it's $2 per person. So for each person that's added, $2 is being added. Essentially what that means. So, an example of rate of change being positive. Rate of change can also be negative depending on the situation. Find the rate of change of the amount of water in the pool relative to time. So they're comparing water and time. Rate of change in the amount of water over change in time. So once again, we do the same analysis. In terms of time, 2, 4, 6, 8, 10. Time is going up by 2. But notice that for each figure for the water, they're going down. So we need to figure out how much. So we do a simple calculation. So it's going down 4.8 gallons. So for our rate of change, that's negative 4.8 gallons over 2 hours, or negative 2.4 gallons per hour. So again, the primary thing, especially if you have a table, figure out what is the change on each side and simply divide out the 2 changes. Now since we're dealing with a linear relationship, the change on both sides should be equal. Should be the same throughout. In other words, you shouldn't see a 2 and then an 8 unless they're spaced out enough for you to still identify a linear relationship. Which later on in this unit, we'll look at examples in which that does occur. That can use our calculator to help us out. Any questions on 1 or 2? Alright, there might be one more application of a rate of change, and then we'll delve into slope. So, example 3. 1.5 hours, you drove 180 miles on your way to a college visit. After 4 hours, you've gone 570 miles. Find the average rate of change in your speed in miles per hour. How many miles would you have traveled after 6 hours? So this is a two-part question. You need to find the rate of change, and you need to figure out how many miles you traveled after 6 hours. So this is a two-part deal. Let's first look at what was given to you. 1.5 miles, you drove 180 miles. 4 hours, you drove 570 miles. So in terms of the table, you have your hours, you have your miles, 1.5, 180, 4, 570. You don't have to rewrite it as a table, I'm just showing it in the video. So, first thing is to find the rate of change. Change in miles, change in hours. So on the hours side, 1.5 and 4, you're adding 2.5 hours. 180 to 570, that's the difference of 390 miles. So 390 miles over 2.5 hours. You now have enough to find your rate of change. Under 56 miles per hour. That's 20. Any questions before we continue?
Mr.
Go ahead.
I have a question, but I forgot to mention the cable a little bit.
You say what?
I forgot to mention like the minute, but I think we're 2 minutes late.
You can type that in the chat, but I'm not worried about that. You're good.
Alright.
So, we got the rate of change. Now we have to figure out how many miles we would have traveled after 6 hours. So, we ended up at 4 hours, 570 miles. I want to know after 6 hours, where am I at? So, how can I figure that out? Knowing that I now know the rate of change. Any guesses on what I can do?
156 miles, 6 hours.
That'll work. You know how much time you went. You know the rate of change. So 6 hours times 156 miles per hour will easily tell you that you've gone 936 miles. you know how many miles you're going in 1 hour, you can find how many you need to go in 6, 8, 12, 50. You can find whatever else you need from there. So questions 1, 2, or 3 before we move on to slope. All right, then let's do slope. So rate of change is the application-based format for slope. So slope is when you're dealing with an actual line. That's the steepness of a line. And of course, as you probably remember, there are 2 ways to find the slope. If you have a graph, rise over run. If you have 2 points, the slope formula, y2 minus y1 over x2 minus x1. So let's first start from a graph. So if you have a graph, then primary thing to do is to find 2 nice and neat points that are on the line that line up with the grid itself. So I'm going to choose there and there. Then I'm looking for 2 relatively easy points to work with. So now I do my rise over run. So start at my lowest point. So I have to rise 1, 2, 3, 4. And run 1, 2, 3 times. So rise over run would be 4/3. Now, if you started from the top and worked your way to the bottom point, that would have been down 4 and to the left 3. So that's -4 over -3, which is still 4/3. And some teachers teach it differently. Primary rule of thumb, anytime you go up or to the right, that's a positive movement. Anytime you go down or to the left, that is a negative movement. So whether you start from top or bottom, that's more so up to you. Problem 5, we have a little bit of a special case, because all you have is a horizontal line. But we can still do rise over run. 2 points. As far as my rise goes, I'm not going up, I'm not going down, so my rise is 0. So for my run, pick a point, the other point. So if I'm going from right to left, that's 1, 2, 3, 4, 5, -5. If I was going from left to right, that's 1, 2, 3, 4, 5, +5. Does it really make a difference? No. Because since the top number was 0, 0 divided by anything is 0. And that's true of all horizontal lines. For a horizontal line, slope is 0, period. Horizontal lines have 0 slopes. Vertical lines, which we will get into in a second, also has a special type of slope, that being undefined. Any questions with a graph? Alright, so let's work with 2 points. So examples 6 and 7 are similar to what you would have done on the unit test with the first extra credit problem. So, example 6, -2, 7, 4, comma, -3. Labeling your points is optional, although I always suggest it. So, y2 minus y1 over x2 minus x1. So it's -3 minus 7 over 4 minus -2. -3 minus 7, -10. 4 minus -2, 6. So you get -5 over 3. Quick, easy, relatively painless. Example 7 works the same way. Again, label your points. That will help you. So we get 3 minus -5 over -1 minus -1. So 3 minus -5 is 8. -1 minus -1 is 0. There is no way you can divide by 0. So this is undefined. So as I mentioned, this represents a vertical line. If you were to have plotted these points up graph, -1, -5, -1, +3, that's a vertical line. So vertical lines have undefined slopes. Vertical lines have undefined slopes. Questions 6 or 7? So, as a basic recap, there are 4 types of slope: positive, negative, 0, and undefined. So example 4 was an example of a positive slope. Example 6 was an example of a negative slope. Example 5 highlighted 0 slope. And example 7 gave us an example of undefined slope. So 4 types of slope. So definitely 4 types of slope. So we found rate of change. We found slope using a graph. We found slope using 2 points. Let's find the slope if we're given an equation. We can also find the slope of a line if we have an equation. So one of the ways that can be done is using standard form. We'll get into that in a second. But we can also find the slope using slope-intercept form. y equals mx plus b, that glorious formula. So if it's already written in slope-intercept form, then the slope is simply the number next to the x, down. So in the case of example 8, y equals negative 4/5 x plus 2. The slope is the number in front of the x. That's that. Now, if the equation is in standard form, there are two ways to go about finding the slope. One, rewrite the equation in slope-intercept form and find the slope. So this is why we learned how to rewrite equations and formulas back in unit number 1, so that we could rewrite something in slope-intercept form. So negative 3x plus 9y equals 22. We need y by itself. So add your 3x. And then divide everything by 9. So once we do all of that, line it up against slope-intercept form. So your slope is 1/3. So take the equation, put it in slope-intercept form. Now, that's one way to do it. Now, if you're solving out the problem and you know that you're in a little bit of a time crunch, there is another way to do it if you are in standard form. So standard form is ax plus by equals c. So as long as you can identify a, b, and c, then the slope is equal to negative a over b. So let's look at this formula again. So this means that a is negative 3, b is equal to 9, c is equal to 22. So to calculate the slope, that's equal to negative a over b. So since the negative is in between, either move it up to the numerator with the a, or move it down to the denominator with b. Don't leave it in the middle. So since a is negative 3 and b is 9, so we have opposite of negative 3 over 9. The opposite of negative 3 is 3. And 3 over 9 reduces to 1/3. So you get the same slope. In the end, you still get the same thing. So in your case, unless they tell you to rewrite it in slope-intercept form, then you have a shortcut to get around. If you don't want to be bothered with the shortcut, you just rewrite it in slope-intercept form. It's not going to hurt. Questions related to 8 or 9 before we do the last part? Last thing that we'll touch on today is how to find the missing coordinates given the slope and a point. So this means I'll give you 2 points, 2 numbers have 1 point already filled in, 1 point with some missing value, and then the slope equal to something. So that's an example of how the problem will present itself. One of the 4 coordinates is missing, but they give you the slope. So using the example that I did for you, I'll talk you through it. First step, substitute all the given values into the formula. So 4, 5, 7k, and a slope of 1/2. So the first step is simply plug in what you got. Plug in what you had. Step 2 is to simplify it. 1 and 2, I can't do anything with. K minus 5, I can't do anything with. 7 minus 4 is 3. So step 2, simplify where I can. And step 3 is to actually solve. So 1/2 equals k minus 5 over 3. So here we'll get into cross multiplying. So 1 times 3, 2 times k minus 5. Notice that k minus 5 is in parentheses. 1 times 3, 3. Distribute the 2. And then solve the rest of the equation. You get 13 over 2. So your cross multiplying is always an avenue for you if you have two fractions set equal to each other. Any questions on the example that I already had worked out before we do 2 more to finish up the game? Alright, so let's do 10 and 11 and wrap this up. Find k such that a line passing through 5, 2 and k, 12 has a slope of -5. So first thing you need to do is put everything into the slope formula. So x1, y1, x2, y2, and that's your slope. So -5 over 1 equals 12 minus 2 over k minus 5. Plug in everything the way you normally would. Then you try to simplify it. -5 and 1 you can't do anything with. 12 minus 2 becomes 10. K minus 5 is stuck that way for the moment. Any questions before we continue? Alright, let's keep going. Now we cross multiply. -5 times k minus 5 equals 1 times 10. So you get -5 plus 25 equals 10. So negative 5 equals negative 15. K equals 3. So in other words, if I take 3, plug it in for K, and then find the slope, I'll get negative 5 as the answer. Any questions before we do example 11 and close out? Of course, if you have questions later on, I'll be here for learning time after school to take those questions. So, problem 11. Label your points. Substitute them into the slope formula. 3 over 2 equals negative 5 minus K over 3 minus negative 3. First step still the same. Plug in what you have. Second step is still the same. Simplify what you can simplify. So 3 over 2 would stay 3 over 2. Negative 5 minus K over 3 minus negative 3 is 6. So you simplify what you can. Now that everything is simplified, now we're going to cross multiply. So 2 times negative 5 minus K equals 3 times 6. Then it becomes a basic equation to solve out. Negative 10 minus 2K equals 18. Negative 2K equals 28. So K equals negative 14. So it's an application-based problem involving the slope. Any questions, 10 or 11, before we wrap this thing on up? 10, 11, or anything that was done in section 2.3. We are now done with section 2.3.